Alright, now we have a coding interview question, palindrome number. Here's the problem statement. Determine whether an integer is a palindrome. An integer is a palindrome when it reads the same backward as forward. If you are given this particular integer as input, it reads forward 1 to 1 and also backward it reads 1 to 1. Here we see this integer is a palindrome because it reads the same forward as backward. If you are given this particular integer as input, if we reverse it, then it will be like this, 1 to 1 minus. So this integer and this integer is not the same. So this is not a palindrome. So for this input we should return true. For this input we should return false. If we have this integer as input, now if we reverse this integer, we see 0 1. 0 1 and 1 0 are not the same. So this integer is not a palindrome. How we can solve this problem? If we see this true condition is true, then we should return false. Because negative number is not a palindrome, and if a number ends with 0, that number also is not a palindrome. Now let's see how we're going to solve this problem. If we have this input, then how can we solve this? First, we can just reverse this integer, right? And then we're going to check the reversed integer with the given integer. If the two integers are same, then we're going to return true. If not, then false. To reverse an integer, we might have an overflow. To overcome that, we can solve this problem by reversing the half part of the given integer. We check if the length of the given integer is even, then we're going to split the integer at middle. Then we're going to reverse the second half, this half, right? So it will be 12. And then we're going to compare the second half that we reversed and the first half. If we see those parts are same, then we're going to return true. And in this case, we see this 12 and here also 12. So in this case, we should return true because this integer is a palindrome. If you're given an integer of odd length, then how we can solve this problem? We're going to split this integer right here. Then we're going to reverse the right part. So it will be 12. When we see we have odd number of digits in an integer, then we're going to remove the last digit from the reversed part. If we remove this number 2, then we have here 1. So we see 1 and here the left part we have 1. So that's equal. In this case, we're going to return true. If you're given integer like this, and also we see here this integer contains odd number of digits. So in this case, we're going to split this number right here and then we're going to reverse the second half. Then it will be look like this, 1, 2, 3. Then we see here this integer contains odd number of digits. So we're going to remove the last element from reversed. And then we have 12 and here also we have 12. We see 12 and 12 is a match. So we're going to return true. Now let's see how we can implement this solution using pseudocode. First, we're going to declare a function name is palindrome that takes the given integer n. Let's suppose that we're given this integer 1, 2, 3, 2, 1. Then we're going to check if the integer is less than 0. That means if the integer is negative, or if the integer ends with 0 and the integer is greater than 0, then we're going to just return false. Then we're going to declare a variable reversed num equals to 0. This variable will store the reversed of the second half, this half, 3 to 1. Then we're going to run a loop while n is greater than reversed num. Then we're going to pop out the last element from the integer. In this case, this is 1. Then we're going to append this digit to this variable reversed num. So it will be 1. Then we're going to remove the 1 from this integer. N becomes 1, 2, 3, 2. For next iteration, we see n is greater than reversed num. So reversed num equals to 1 and n equals to 1232. Then we're going to pop the last digit from this number, and that is 2. Then we're going to append the last digit to this variable reversed num using this formula. Reversed num equals to reversed num times 10 plus pop. So it will be 1, 2, and then we're going to remove the last element. So n becomes 1, 2, 3. Then for next iteration, we have n equals to 1, 2, 3 and reversed num equals to 12. So this condition is true. Then we're going to pop out the last element, in this case that is 3, and then we're going to append it to this variable reversed num. Then we're going to remove that. Then we see we have reversed num, and that is greater than the integer 12. So this while loop stopped here. Then we're going to return n double equals to reversed num. So we see n equals to 12 and reversed num equals to 1, 2, 3. So this condition is not true. So this is evaluated false. This is for when we have even number of digits in a given integer. And this part is for when we have odd number of digits in the given integer. In this case, we're going to remove the last digit from reversed num, and then there is 3, and you have 12, and here also n equals to 12. So that is true. So false or true. So false or true evaluated true. So it will return true. And this is my solution to this problem. And this solution will take bigger of n time complexity, and it also takes constant space complexity. Hope this concept was clear. If you have any question, if you have any doubt, let me know. Thanks for watching this video. I will see you in the next one.